Hello. The purpose of this video is to show the midterm demonstration for Group 20 in Senior Design this semester. Our team members are myself, Noah Weeks, Ashley Hanzelka, a CPE major, James Ventimiglia, an electrical engineering major, and Junior Justine, also a electrical engineering major. So the first thing that we show is just a general walk around of the entire plant environment. This includes the front and the back, where we have the power supply, water pump, and valves. And here you can see a full viewed picture of the entire shelving. Here's a close-up on the water pump. You can see the valves and the pipe, as well as the inlet line to the water tank. These solenoid valves will be important later. Now here we see our first initial test. The point here is to deliver water into the system remotely. So we will go ahead and click the on button for valve 1, and we see water come out of valve 1, but importantly, it does not come out of valve 2 or 3. And whenever we click off, it shuts off within 5 seconds to meet the spec. This is a second run of the same thing, just to show that we're spec compliant here. Turn it on, and within about a second, we have water flowing into the plant environment. And whenever we go to turn it off, we see that the water stops. And next we get a look at the web server that shows the soil moisture information. Ashley will talk more about this in a second, but you can see here that we have the actual moisture sensors put into the plant pots, and it is returning values.
Using Xcode alongside Flutter's debug tool, we were able to wirelessly start a debug session, which allows us during development to see how our app is interacting on the mobile device. As can be seen, almost all features are currently interacting as could be hoped, including a way to change any moisture thresholds, turn on and off auto watering, as well as notifications, and connecting to the ESP32 device. In the future, we will scale this up even further by attaching the database images for each plant instead of these icons, as well as allowing the user to connect to their environment, which will add a new tab here at the bottom. This demo on the ESP32, a web server at port 80 is started with the extension \moisture. Now all the values needed from each of the soil moisture sensors will be stored in a JSON document file, as can be seen here. Now truly, this will update on refresh or for any get post request, but as can be seen on each refresh, the values are actively updating. The polling rate here is set to once every second. So on this more visually enhanced view, you can see that those values are actively changing every second as well, and these values will update independently of each other. So soil moisture sensor 1 is going to react once the first soil moisture sensor is exposed to a different range. Similarly, when we get to soil moisture sensor 2, the values are going to update regardless of the other. And for soil moisture 3, the same thing will happen. All of the soil moisture sensors are working regardless of the other's performance.
So the next thing that we'll look at is the temperature sensor readings, as well as the light sensor readings. You can see them on the ground there. And whenever we run the following code, we see sensor values for both the light sensor and for the moisture sensor. So here I lift up the light sensor closer to that LED light strip there. That will simulate what we will have in the environment. And we can see here, if we take a little pause, that the light sensor value for sensor 2 has increased. Notice the lux value from 1 and 2 is completely different. 1 and 3 are both sitting on the ground, so they report a rather low value, whereas sensor 2, which is pointed towards the LED light strips, reports a much higher value. So the next portion of the video will require a little bit of explaining. One of our engineering specifications is that every environment should be separate from each other. The readings of the sensors, therefore, need to not be affected by the light or moisture inside of the other chambers. So what I'm going to demonstrate here is that even whenever a light sensor is directly on the other side of a sheet of plywood, the light doesn't permeate from the LED past. And we'll show that by showing first some ambient light values for the sensor, and then putting it on the other side of the plywood and ensuring that it's not affecting the reading on that side. So we'll look here. We see the initial value here for the lux readings are, somewhere around the 70 into 80 range. The sensors are sitting in slightly different positions, so we get a slightly different value for each. But if we kind of snake this one through here and hold it on the other side of the plywood, facing up like it will be in the chamber, you can see the lights there shining. And if we go ahead and scroll down here and take a look at the value, we will see that, and perfect, you can see 7 lux for sensor 3, meaning that the light is not permeating through. So to end the video, let's talk a little bit about engineering specifications. Throughout the video, we talked about some specifications that we specifically met, including the electronic solenoid valve response time and the soil moisture polling rate, to choose 2 examples. But I'm going to go ahead and pull up the spec sheet here, put it on the screen, and explain a little bit how we plan to meet some of the other specs. So in terms of accuracy, we have purchased off-the-shelf moisture sensor and light sensors, and we're going to compare the accuracy for those 2 parameters, being the light sensor and moisture sensor accuracy, to some off-the-shelf products. For the temperature sensor accuracy, we're not doing any feedback control with temperature, but we will compare it just to ambient air temperature that you can find readily available online. Some other things like the water pump flow rate and pressure can be measured using off-the-shelf pressure valves, so we will be doing that. And I'll go ahead and show a picture on screen of the dimensions of the shelf, since that is a spec that I guess that we can show here has been met. So lastly, let's talk a little bit about what needs to be done between now and the final demo. So you can see through the video that we already have all of the PCB boards working. We have the web server working and the app working. So at this point, it's more cleaning up the wiring, let's say to the light sensors and to the LED lights themselves, and also some calibration is needed. We're going to do soil moisture testing in the future for different types of soil. That was one of our stretch goals, was to allow the user to pick a soil type, and then we calibrate the sensors for a variety of soil types. So that is our plan moving forward.